some suggestions. Have a look at this first one. Please mark, it's not an equation. Yeah, you can't solve this thing. You're not going to end up with an x equals something because this thing's not equal to anything. Like it's got x's in it. I'm never going to be able to get rid of them. That's okay. I can still simplify it. What would I do? Any suggestions? Yeah, Sandra?
So I would put the common denominator as 12.
Yeah, very good. When you've got two fractions and they're speaking different languages, even if they were just numbers, like a half and a fifth, you need a common denominator. That's perfect, okay? And 12 will do it for us. So if we go to question 1, what do I have to do to the first fraction to make its denominator 12? Yeah, I got to multiply by 3. So, of course, if I multiply the denominator by 3, like I can't just go around mucking around with fractions because I want to, because it's convenient to me. I've got to multiply the, what's that thing on top called? The numerator, I've got to do that by 3 as well. So I'll go x times 3. Are you happy with that? You see, it's the same fraction, yeah? Multiply the top, multiply the bottom, we're fine. What about the second fraction? What am I going to multiply by this time?
Times 4.
Yeah, I'm going to multiply by 4. That'll give me the same denominator, yeah? So I'm going to use some brackets here, and that's 4 times 3 as well. And this is why we do this, because now I've got 12 and 12. These guys can talk to each other now, yeah? What if I got on the top 3x, take away this guy? Okay? Are you happy with that? Do you see what I did? Two fractions combined into one, okay? I possibly could have taken this and expanded it into the next step, but I want you to pause for a second, put on your teacher hat for a minute. What do you think this question is trying to check for? What skill do you think it's looking at assessing? What do you reckon, Ray? Say it again. Okay, if you know what to do with this factor, right? The fact is the critical thing, particularly the fact that it's got these negatives in here. Easy spot to not be sure what you're doing and maybe miss some of the negatives, okay? So I'm leaving that to an extra step. 3x, take away, when I do, get rid of the factorization, 4 times 2x, 8x, okay? What happens with these two here now?
Positive.
Yeah, when you multiply two negatives, you're gonna get a positive, and 1 times 4 is just 4. Happy times? All divided by 12, and I only have one more thing I can do.
The like terms.
I'm going to collect like terms. So 3 take away 8, negative 5. And I'm done. I could write it in either order. I could make it 4 take away 5x. That would work just fine. It's the same answer.
I did it differently and I got a different answer.
Do you want to explain what you did?
I just did that. It was a different answer.
That's okay. We'll just help us.
I did times 12 on each side.
Okay, so did you had this.
Yeah.
This is where we started. So what did you do to each thing?
Times 12 and 12 times.
Hold on, wait, say that again. What did you multiply by 12?
Both.
So multiply this by 12, and then multiply this by 12. Is that what you did? And I'm guessing you got this.
That's what I got.
Yeah, no, maybe. Okay. All right, now let's just think about this because this is so important. This is why we're reviewing it over and over and over again.
Oh, hang on. Yes.
What?
Wait, I did.
Is this what you got?
Hang on. I did it.
How did I know that was what was going to happen?
Because you were a teacher and you've done this many years.
Yeah, I got that.
Partly, okay. But mainly because, have a think about this for a second. Please closely look at this line. Ow, sorry. I closed the door on my hand today and it's like all bruised. Anyway, have a look at this line and compare it to this one, okay? Look closely. Now, do you see that this and this are exactly the same thing? I just kind of rearranged it a little bit, right? Like, this fraction here is identical to this fraction here. They're the same fraction, yeah? Why did I change it? Why did I make it look different? Yeah, common denominator was what I was after. But the important thing is, this is the same fraction as that in exactly the same way that, for instance, a half and 3/6 and 5/10, all the same fraction. They're just dressed up differently. Does that make sense? Now I want you to compare that to this one over here. Do you see this is no longer the same fraction as the one I started with? In fact, it's the same fraction multiplied by 12. It's 12 times bigger, right? So it would be a little bit like taking this fraction, and if you multiply by 12, what are 12 halves?
6.
That's 6. 6, a half, clearly not the same number, okay? So I can't change things here because that would actually mean I get a different answer altogether, and I'm making it 12 times bigger. And the reason I knew is because if you make this 12 times bigger, the fraction will disappear, okay? And this is very different to if you have a look at the next question, and what we're confusing is, when you've got an equal sign in the middle, right? Always picture an equation is like a set of scales. It's a balance, okay? If you do something to one side, that's okay, so long as you do it to the other, because then you'll stay balanced, right? You add stuff to both sides, you take away from both sides, it'll work fine, okay? So that's why you can do that if you've got an equation. If, for instance, the question said this.
And it had equal.
Yeah, right? And you see here, it's like, oh look, I made this side bigger by a factor of 12, I did that side, everything's fine, okay? And I got this exact question before. If this were an equals, if it were an equation, then you can balance things out and you can change things. But here, just like I can't change this and I'd like to make it 12 times bigger, just for the lols, right? No, you're gonna end up with a different number. Yeah, different answer. Okay, number 2, we probably won't spend as much time on. I think we're okay with it. Can someone give me an answer? Should be a nice round minus -2? Yeah, excellent. Okay. If you didn't get -2, I'm happy to come have a look at you in a minute. So well done if you got it. Now, have a look at this one. This is a bit sneaky. When you're having a look at a straight line, I'm asking for an equation, right? An equation. Now, usually we say most straight lines, their equation is in this form. Do you recognize it? Is this ringing some bells? Okay, so if you didn't know where to begin, this is the first thing I would have written down when I was solving this question. The next thing I think is, well, what do these letters and numbers mean? In particular, the M and the B. What do they signify? M's the gradient, B's the y-intercept. So if I can work out those two things off of the graph, I'm there. Do you see that? Let's do the easy one first. Which is easy to work out, gradient or y-intercept? Y-intercept. You just read it off the graph, yeah? And it is done, okay? So this is going to be +3. Do you agree with that? That's what B actually is. Gradient takes a little work, but not that much. What do you see as the gradient? Looks like 2 to me. You can pick any nice convenient point, like say, there. There's a nice triangle. All of the points are on nice grid lines, right? You've got a rise and run. So the gradient's going to be 2. You see how I got that? So this M, in fact, is 2. I'm done. Happy times? Does it make sense? Okay. So again, let me just rehearse that, right? I think about, what's the question asking? Looking for the equation of a line. Every straight line I've been working with is in this form. That's on the formula on the data sheet, I should point out. And then you just want to think about what each of the pieces means, come to your graph and interpret it. Does anyone want to clarify before I move off that question? Okay. Yeah? No? I'm happy if this is a double. You can ask me later if it occurs to you I have a question to ask. Okay. All right, now, last one. I'm going to... yeah, I'll bring this back down. Okay. Now, who got this one out? Hands up straight. Don't tell me, don't tell me the answer. Just hands up. Keep your hand up if you're confident that you have the answer. Okay, a good number, hands down. Don't give me the answer yet. I want you to explain to me, like, what was the first step that you did in having a look at this and coming up with something like the y equals 2x plus 3? Someone want to give me a suggestion? What was the first thing you looked at?
The 0.
Okay, you looked at the... I tried things out till I got something. Okay, you looked at the x equals 0?
So yeah, there's obviously 5 when there's no number, like when there's 0, like so. Then when it was 1, there was 2 extra. So.
Okay, yeah. So all right. So you've said a couple of things in there. Let me just sort of grab onto. Firstly, maybe the easiest thing is every time you're going across 1, right? Every time you go across 1, you're going up 2. Do you see that? This is across, and this is up and down. Yeah. So if you're going across and then going up, what does that number signify? Which feature is that? That's called the gradient, right? Like that's run, that's rise. So I read straight off that you have a gradient of 2, actually just like this question, okay? So a gradient of 2, I'm gonna write down, this is number 4. The first thing I see is m equals 2, okay? And I'm reading that off the fact, if you had this on your page, I'd write like, arrow plus 2, etc. That's what's going on, okay? I need one more feature. You saw that in the previous question. I need the y-intercept. Which one of these numbers is the y-intercept?
5.
Yeah.
Now, it's going to be 5. How do we know that it's 5? What tells you it's 5?
The x is 0.
The x is 0. You can see the y-intercept, right? Brett nailed it, is where x is not equal to 1 or -1, x is equal to 0, right? So that's how we look up on the graph when we see 3. Here you don't get a graph, you get values. X equals 0, y equals 5. Okay, does that make sense? Now this would have been a harder question if I could have taken off these first 2 data points. how would you have worked it out if that's all you saw? If this, what did I have? 2, 3. How would you have done it in this case? Because you still can. You've already worked out the gradient. It's still +2 +2. How do you work out the y-intercept now? Just give it a go. Now we can, right? But the whole point of mathematics is there are patterns and we can take advantage of them and we don't have to do trial and error. I do you want to give a suggestion?
It's, you know how it's a pattern going up? It'd be the same pattern like going down, so you just go down to 0.
Very, very good. So the pattern going forward and the pattern going backwards are the same pattern, just in opposite directions, right? So if I'm adding 2 going this way, then if I actually want not 4, 3, or 2, or 1, I want 0, then I've just got to go 2 steps further. I've got to subtract 2, then subtract 2 again. That's going to give me 5. And you can kind of see it now that I have the numbers there. Does that make sense?